the cloud, and you need the computing power for that to be able to happen. But if I go reverse and then talk about communicate and connect, right, and you start getting down out here, the final device that is pulling data from those, from those motors over there, or a device that's in a turbine that's monitoring the health of that is actually a very simple thing. You don't want complexity for various reasons. Because the moment you add computing power, the moment you add bandwidth, the single biggest thing that suffers is power. You just can't, unless you plug it in, and you don't have a lot of places where you can plug in these devices. A wearable, right? My watch that I wear, I got to charge it every 2 days. This is just a basic Fitbit. The Apple Watch that's come out has probably got a life of, it's like you need to charge it every day if you're going to use it intensively. So there is a power aspect that comes. So you have a power curve and a performance. So it's a standard power performance curve that you need to optimize on. And while the world was headed in that direction of doing all of these things better, faster, more, richer, IoT actually said, hey, hold on, this is not what we want. And they actually turned the whole thing around and you said, I need a simpler compute. I don't need so much of computing power. I don't need, what am I going to do with 1 gig of bandwidth, right? I don't need, if I'm just going to be sending the health of a turbine, if I'm going to be doing a meter read, for example, right? I'm going to talk multiple segments. If I'm just going to be collecting data of my thing, I don't need that kind of bandwidth to push it out to the cloud. I need a smaller pipe. Essentially, both of them lead to the saving of power. The moment I cut down compute, all of us have seen this, right? The moment our phones hit 25% or 10%, automatically the screen dims out. Automatically a few applications cut out. All that's trying to do is trying to save power. And that is the essence of the success of Connect in an IoT world or in an industrial IoT world. When you can connect it and then there's a power source available, you're okay. But if it's something out there, remote in the field, the rest of the world is not as dense as India. Right? India is one of the most densest populations. But if you look at North America, there are just flat open land, and then you would have a cellular tower, and then there's a sensor that's monitoring that and then trying to put out data. There's a turbine that's monitoring, putting out data. There are logistics, there are fleet management that's collecting data. But the nature of it all is simplicity. And the reason you need simplicity is because you need to save on power, you need to save costs. Because a quad core, if you put a quad core processor and if you put a quad core LTE processor to just monitor a turbine, the cost of that damn device is probably going to be north of $40, right? So you're going to be making a $40 device. And industries will not, and industries and firms will not invest that kind of money in getting their assets connected. So that is the interesting challenge that we had. The entire world, and we were all running away with making things more complex. And IoT came in and said, wait a moment, I don't need that kind of computing environment. Make it more simpler. I don't need that kind of bandwidth for me to be able to get it. Make it simpler, make it smaller, lesser. And that is the engineering challenge in some ways. So you now have a lot of organizations, including Saskin and product organizations across the world, trying to engineer for complexity, and IoT is engineering for simplicity. And that is the first of the challenges that we sort of need to face. Have we solved it? Not entirely. Because the second aspect is important in understanding the evolution of IoT. The second aspect is, unlike mobile phones, my mobile phone, your mobile phones does the same 5 things really well. You can call, you can take pictures, you can watch a video, etc. It does the same 5 things really, really well. But with IoT, because of an industrial IoT as well as consumer IoT, it doesn't matter. The number of segments it addresses is immense. You can put it into a manufacturing plant, you can put it into a turbine, you can put it into logistics, you can put it into fleet management, you could convert it into your home, a smart home, into wearables, etc. As you can see, the amount of segments that IoT is like used, it's a term that's used across these things. But the needs of each segment are very unique. And if you create a general purpose sort of a solution on the terminal side, or general purpose thing, and then try to get it connected, you're almost never going to cut it. And it's again comes back to a general purpose thing trying to do special things versus a very specialized thing doing a job. So the second challenge in IoT is really trying to figure out the segment, figuring out the use case, and figuring out an end terminal system that suits that use case. If you use a general purpose approach, the costs go up again, and you're going to have suboptimal performance for each of these things. So that's the second challenge. So trying to engineer for complexity versus engineering for simplicity, trying to figure out the right size, right? It's just really, it's one size does not fit all when it comes to IoT. You actually have multiple segments, multiple use cases, multiple scenarios that you want to be able to monitor and get going. And the third thing was very interesting, I think again, Mr. Chetan covered it, which is the moment you connect something, you expose it to vulnerability, which is security, right? So you absolutely need to take care of security. You need to figure out how do you manage security. Becomes complex again a little bit, right? So we were talking about simplicity and now we're going to talk about security. And to be able to assure security, you need to bring in a certain amount of complexity into that end device. So these would be the three top of my mind sort of things that we grapple with over the last, IoT, I think we started toying with it about 3 to 4 years ago. As we've been evolving with the experiences that we've had as a service organization and interacting with companies that make products, these are their challenges and these are the challenges that we are trying to solve. From a terminal side, as I said, the cloud, the analysis part is all cool. You have the Amazon cloud, you have Azure, you have a whole bunch of stuff that you can do. Once the data gets out of this device, that part of the problem is solved. The problem is here, doing a cost-effective way to connect, collect, and then push it out. I think those are the sort of things that me and my team in Saskin are trying to solve. We don't have all the answers. There is again no one size fits all, and we hear brilliant numbers like 20 billion connected devices by 2020, 50 billion by 2025. Pick a number, and it's probably you hear analysts give you that number. But that's not going to happen unless you solve this problem on this side, and that is the biggest challenge, right? We talked about complexity and simplicity, I talked about security, etc. But the second challenge which I talked about, which is the number of segments that are adopting IoT, and the volumes in those segments aren't great, right? If I'm trying to outfit an engineering plant, right? We're in conversations with one of the leading tobacco companies around the world, trying to instrument their plant. Their needs are so unique that even if I went to yet another tobacco manufacturing plant, I wouldn't be able to reuse that solution. So I have to create a custom solution here, tweak a few things around, create another custom solution over there. When you start creating custom solutions, the problem is cost. So again, you start actually, you engineer something for them uniquely, and then you're just building up. I'm hoping at some point in time, and it's going to happen, as Industry 4.0 evolves and we get to a standardized way of doing it, you will have an approach that brings it all down to a standard monitor, a standard way of trying to talk. The protocols the multitude of protocols that are there, those should sort of even out, and we should get to that. But that's not a solved problem as yet. Those are some of the challenges that we're dealing with from a Saskin perspective. It's one of the thanks.
Thank you, Ashwin. The defense and aerospace domains are predominantly two areas where technology gets introduced before any other domain. And most often, people like you and me, I will not include Kalyan Rao into this, the rest of us here have no visibility of what is happening there. But we all know that the technology gets introduced in the defense and aerospace industry. So I would like to request Kalyan Rao to tell us how IoT has been introduced in the defense and aerospace sectors, what purpose they serve, what do they realize, and then open a little door for us to know what's happening behind the iron curtain.
Thank you, Bala. I think maybe I'm a minority here, and maybe Bala may be one of them who have worked in defense and aerospace. But the technology what we have used is nothing different, exactly the same. So as he pointed out that many technologies that got introduced from research and development exclusively meant for Department of Defense by US, whatever they made. So all of you may be aware that even intranet or internet was invented by those people when they started doing their research. Same way, connected device or Internet of Things, the avatar or a very old avatar is the once again, research done in US for Department of Defense. And every time we call, the necessity is the mother of invention. So the US guys or the defense guys never fought their war in their soil. They all fought the war somewhere outside, 5,000, 6,000 miles away, either Middle East or Vietnam or something else. So now, how do you fight a war sitting the commanders and the decision makers sitting in US, and actually the field, some soldiers are there with all the guns and observing post. So there is a need to connect. So that's how something like 30-35 years before, they introduced a thing called network-centric warfare. So warfare cannot be on the battlefield, it has to be networked. So that's how we started, and the entire observation, whatever is happening in the far off in the battlefield, the data was sent to the internet. Net, I will call, I don't even call internet. Whatever communication media, the first level communication media for the defense guy is a tactical radio link with a very low bandwidth, maybe 19 kbps or something like that when I say 30 years before. But of course the satellite communication was very much there at that time. So the entire data was collated, sent through satellite communication to the commander in US, and there they really have the common operating picture of the entire area. Where are the threats? Where are their weapons aligned? And what are their roles? And defense guys, they were only a hierarchy. They are not in the flat world. They cannot take their own decision. The whole thing will go off. The nation will start fighting. So everything they will aim for a command from somewhere else. So the decision was made there, and once again the communicated. So this is a network-centric warfare which was going on. And if any of you have attended any of the defense seminar around 25 years or 30 years before, this is the in-thing network-centric warfare or command and control software. And every time we call, there is a terminology called, I don't know how many of you have heard, it's a OODA loop, they call, OODA. In any defense terminology, anything, they first say how to reduce the OODA loop. What is the OODA loop? Observe the battlefield, then orient your actions, then decide, then act. So your observation and act is going to happen in the battlefield. Your orientation and decision making is going to happen somewhere else. Higher echelons, either at a regiment level or a team level or a higher headquarters, anywhere it can happen. So this is the loop they were trying to shrink, how to make actions faster. Faster than our adversaries make any move. So this is how the whole network-centric warfare was coming, and then the sometime in 1999 that Internet of Things came. So the moment the commercial world took over this concept, then the technology had exponentially grown. As you really pointed out that how microprocessor became now cheap, shrinked, cost is cheaper, and the connectivity has improved a lot. You mentioned from somewhere from kbps to now we are all talking like Mbps and all that. So this technology, what has gone up, unfortunately, the defense and aerospace field is unable to utilize. Because in commercial world, we don't bother, no, we use our cell phone, something happens, okay, there is a switch on, then you work, you go ahead. But in defense, you cannot do that. Anything, any message, anything you get, it has to be authenticated. Somebody should not have pumped something else, and whatever you talk, somebody should not hear. So there are a lot of restrictions if you want to use anything in defense. They expect end-to-end encryption through air interface. Anything goes in here, there is a encryption we should have, and somebody should certify that, okay, this communication you can use it. So even now, when we have the commercial world in megabits per second, still we are struggling in defense and aerospace, something like 1 Mbps and trying to go to a little bit higher level. So in India also, same network-centric, we have really introduced. In fact, I had worked on the project around 20 years before in Bharat Electronics. Maybe I'll give a small example so that all of you will understand. So this is for the artillery fire control system. So all of you maybe, if you want to see a battlefield, you have to visualize your any of the movies or a book or a news item what they fight. So artillery fire control system is going to happen very close to the border, around 50 to 100 kilometers away. So the artillery guns are lined up with the various kind of types of guns, 105 guns, they say 120 gun, mortars, high angle, low angle firing. So how the actual function was happening was, there is a observation post slightly at a higher level. So the soldier is having a binocular or an infrared camera or whatever laser, whatever is there. So he is observing the entire area manually. Whenever he finds a threat somewhere, then he talks through his radio, voice radio, which is an encrypted radio, to somewhere else. This is he will say that lag long at this particular height, I am seeing a threat. So similarly, a lot of 2-3 observation post people will be sending, and the commander will have a big paper map, digital map nahi, paper map. 1 is to 50,000 or 100,000. Then they point that particular thing. Okay, these are all the threats over here, and then they look at how to engage them. Then they have lined up a lot of guns and other things, something else, and they have all their capabilities also. The gun position also they will put it in the map. Then they will see from here to here if you want to go. Is there anything in between? Height is different. Is there any hillock? Is there anything else? So they try to find out how to which weapon can engage, the weapon should move or all that. So that's all decided through a mathematical calculation by looking at the paper map. Then they decide, okay, this is what you have to fire. Then once again through radio they will communicate and then they will fire. After firing, once again he will observe what was the effect. Because anything you send, you fire due to wind and other thing, it will not be falling in the same place. No, once again they will say the correction and then he is going to change the charge and elevation he may change, he correct it and once again he will. So the whole thing which I said about OODA loop, it used to take around 45 minutes to go one full round and really to eliminate that particular threat. So that is what we made into a completely digitalized, connected, I'm telling 20 years before, not now. So using the existing, that time, tactical radio network, it was converted into digital network first from the voice. So whatever GPS was used, position data, height data, threat data, everything was sent through the radio automatically to the computer. And computer had all the weapons related information inside. Computer had a digital map. Computer had all a 3D dimensional digital map was available. So it used to compute whether he can engage from his regiment or something. If he cannot engage from his regiment, he will send to the higher regiment. You decide wherever you got a weapon, you can engage. So that was decided, and finally that weapon group, he will be getting a angle, bearing, elevation, set, and this is the charge on the gun. So he will set that manually, okay, he will set everything and then he will fire. So I will say that was the first level connected device which they could decrease the OODA loop to something like a 1 minute from 45 minutes. That too with a very low speed radio net. So this is how the network centric warfare came, and then today the entire defense and aerospace is absolutely utilizing the entire commercial whatever digitalization is happening. So the cost is really coming down, but we can't choose and straight away plug it in. So everything you have to give a wraparound. Give a encryption first, then give a ruggedization, that means it should work in -20 to +55 degree temperature, and also even if it falls from here it should work. And then nothing, no communication, somebody can see it, somebody can jam it. So any network we use, radio net, it is not on a single frequency, it is going to hop. It has got 1,000 hops to do within a particular time, so nobody can really see that which frequency it is coming. And also it is going to sense the electronic intelligence, that means anybody is emitting something that will be sensed. Accordingly, this is a radio will be frequency will be set. So the entire digitalization is happening in defense also. Now, olden day soldier, now current day soldier. Soldier is itself, we call soldier as a system. So soldier has got his camera here sitting in this, and he has got a radio connected to his completely digital. So his position is known everywhere. Of course, he will be holding his ration also. So ration, how much the capacity also should be known. And then that is how he is going to the reconnaissance. So when you do the reconnaissance and he does the reconnaissance, if he sees anything, then he is going to just press the button and telling this particular information. So today, we call battlefield management system. Some of you might have heard in the newspaper and all that. It's a huge, completely digitalizing the Indian Army. It's a huge program. We have been planned. We all have written a lot of design review and all that we have submitted. And same thing is happening in electronic warfare also. Electronic warfare is a field where what you don't see, there's the electronic emitting is happening. So these data, directional data and other things are being sent. And those days we used to get a volume of data is very less, around 20 years before. But current electronic warfare, if you see, the data is, what they get from all this is abundant. What we used to call megabytes of code will be available, you should have a processing power for megabytes. Today they are expecting 200 terabytes of information can you process. So whatever we call big data is being used for electronic warfare program now. So really the commercial world, whatever the technology change being utilized in the defense, only thing is in a different form. We all call cloud computing. Can you use cloud computing in defense? No, it's a highly open-ended one. And also if you have a cloud somewhere, somebody bombards there, then all of your defense thing comes down. So you should have always a multiple choice. So instead, cloud computing they are calling a fog computing. That means tactical. You make it a smaller one, make it doable. Whatever you want to have in the cloud, not make it a smaller form, you keep it and keep it mobile. Fog computing, that's what that principle is used. So technically, almost all the digitalization, whatever we are talking, is being used with some extra provisioning given in that. So really a difference in aerospace, even though that started, they are doing the research, but now they are trying to catch up whatever best possible from the commercial. So with that I will stop. Maybe Bala will take some questions, then anything we will share.
Thank you. Thank you, Ram. It was like watching a Second World War movie. It was interesting. First, being the panel moderator, I take the liberty of asking a couple of questions. Ramdu, Ashwin clearly stated what are the drivers for IoT in the commercial world. One is to make it simple, reduce the complexity. Second is to drive the cost down. So, is there a similar drive for introducing IoT in the defense and aero segments?
Yeah, so what I was mentioning is maybe the word IoT may not be used. They are calling military IoT. The moment military IoT means military
MIoT. From IIoT we are going to MIoT.
Yeah. So today the data is, I will say, abundance. So the decision making, as I said, in defense is a hierarchy. So that means everywhere you have to collect information and it has to go to the next level. And of course, local level, some decision can be made whether it is the correct one or not. Today we are talking to audio to text. How can we convert automatically? Something like 25 languages they are attempting. So that information, whatever comes, so finally in the text form it will go to the next level. So everything is happening through the internet, and either I will say not commercial internet they may not use. We all have a bounded intranet within for the defense. They may not allow others to come inside, so that that's a better safe method. So it is really happening, and then the technology, whatever is coming, because what has happened today, the soldier in his house, when he sees his son using all mobile, he gets the same idea, why you are not using here in defense? This fellow is able to use, he knows everything, but I cannot use, I am not empowered to use even my cell phone. You can't use a cell phone. Recently we have made a secure handset for the care DRDO here, completely secure. And they will put their chip and other thing, that's how they do it actually. So this is all, it's even in bottoms up actually. So there is a need to catch up with a particular thing, whatever internet.
Get the benefit which the commercial world has got with the constraints of the defense.
Yes.
Ashwin, you are working as a service provider to number of organizations and a very diverse kind of clients. How do you see the adoption and deployment of the technology across them? Are they uniform? Are they using the IoT technology in the same way across your clientele, or each one is approaching in a different way?
I think obviously it's different, and I think the biggest question everybody asks is, where is the money, right? I mean, where is the money that's going to come? So what if I do this? So big deal, right? If I go and instrument my plant, so what? If I do healthcare, I mean, that's as diverse as instrumenting a plant versus healthcare in the US, right? All of them are instances of IoT. Where there is direct cost, capex or opex, primarily opex, effectively it's just opex reductions that lead to bottom line improvements. seen willingness to invest and we've seen willingness to actually go forward. But it is very slow. It is not a big bang. Let's instrument all our plans around the world. Let's do a POC first. Let's see if this works for this particular set of scenarios. If that works for these scenarios, then it's fine. Then let's move forward. Patient administration. If we give them a device and if it reduces readmissions or if it reduces visits of the patient back to the clinic in a given period of time, it means you've saved money in an overall operating context. Therefore, there are investments going on out there. But then we've also seen that there is, unlike the consumer devices where people are easy, I mean, it's very easy to go buy a new phone. Adopting this into existing deployed infrastructure is very slow because of the challenges in retrofitting, etc. Right? So the whole bunch of things and investments over there tend to be fine, but just the adoption of it is slow. So bottom line, I would say is, if there is a traceability to margin improvement for the organization, we've seen firms actually go ahead and say, yes, we're pretty much interested in doing it. But let's do POC. We'll do a POC, we'll see if it works, then we'll move forward. That's how I see it.
So there is a diverse approach to adoption, and then there is a diversity in the way it is.
Absolutely. And finally, it just comes down to money. Can you save it? That's it.
Thank you, Ashwin. Now I would like to open the floor for a few questions to the panelists. Maybe we'll have some 2-3 questions.
Hello everyone. So I just trying to connect back the very topic of this discussion, right? The landscape of the world that we are living in, right? So the connected devices with respect to that. So when I think of the landscape of the world that is changing and all of that, at least the first thing that I remember is our home. As of now, at least in India, I'm not seeing anything that is changing. Okay, so for example, 3 years back when I first traveled to Europe, I was amazed and surprised to understand that they can even switch on their air conditioning and all of that, set the temperature before they even enter the house using their mobile devices. Even that point of time, the technology was very old for them, actually somewhat old for them. So we are like probably 5 years down the line here, and I don't know whether we are still there, right? So my question is, when are the IoT kind of thing that is going to be really affordable for the world that we live in right now here?
Good question. I think you're absolutely right. There is this, and we always have to look at it from emerging market and advanced market or a mature market, right? Mature markets tend to take in these and deploy these faster. As far as emerging markets are concerned, value engineering is exactly what happens. So you normally tend to deploy something in a mature market, take that product and try and value engineer it down. Case in point being, take a car, right? Whichever vehicle you buy, it's an international model. Look at the infotainment system that you would get in an international. You go to Germany, buy a Volkswagen, for example, and then see the Polo there, and you come back here and see the Polo here. Just compare the kind of things. It's already value engineered down. The features are down, etc. Everything comes down. So for emerging markets, that's primarily the challenge that comes in, which is how do you take something that's reasonably mature and then bring it down to a market like India or any of the emerging markets and then introduce it in a way that will take off quite significantly. And therein lies the challenge. Again, it's a double whammy in a way, because when you don't have, so if you have a solution for a mature market and if you have a different solution for an emerging market, you have more R&D dollars that you need to be able to spend. The return on that is not justified right away. The volumes aren't there. How many of us would, I don't know if you guys watched the Amazon announcement. So now, we had Alexa at the home. Now you have an Alexa microwave oven, right? You can actually talk to it and say, hey Alexa, nuke me something, or turn it on for like 3 seconds or whatever. Of course, you need to go put the food in, of course. But that technology, just because you have that feature, would you replace a microwave oven? Answer is no, right? Just because you have a refrigerator that senses how much milk there is, and there is a way of trying to do that, would you change your refrigerator? The answer is no. So in emerging markets, the needs are very different. We are value driven. And it comes back to the great ad that I think Maruti did it at one point in time, saying, kitna deta hai, right? You can say, oh, this is cool, but the final thing is, what's the mileage I get out of this? So until that problem gets solved, we will see, it's going to be, the adoption here is going to be slow from a personal space. I mean, I would not put money to the from an industry, Indian industry, I think would still go ahead and adopt. Progressive players in the Indian industry would still go ahead and adopt, provided they see the margin improvement.
As part of Larsen & Toubro. So most of the building what we construct nowadays, big buildings, there's a huge building management system. There are a lot of IoT things are happening, especially power control, water control, and many places. So in the design itself, it is not